The next two laws that we will talk about are Charles' law and Avogadro's law. So let's start with Charles' law, and it's a relationship between volume and temperature. So we have volume and temperature. So let's read the statement. It says the volume of a fixed amount of gas, so V at fixed amount of gas, meaning N is constant, number of moles is constant, at constant pressure. So in this case, pressure is constant, it's not changing. Here's the key word, directly proportional to its absolute temperature. So let's put the N and the P in the constant column here. So what's happening is that as temperature increases, the volume will increase as well. And the opposite is true. If the temperature is going to decrease, the volume will decrease as well. So you can demonstrate this at home by inflating a balloon and placing it in the freezer. Come back in about an hour and you will notice that the volume uh, is less now. Okay, the balloon actually shrunk in size and volume. Uh, so we see this all as well as if you use a bag of popcorn, put it in the oven and come back and you'll notice that its size inflated. Once again, the volume inflated. There's water droplets in the kernels, right? The corn kernels, and they actually become a gas, and that's actually the hot gas that they have the warnings about, right? Do not touch. So again, the volume increases. This is a graph about the temperature and volume. Notice that as the temperature increases, the volume increases as well. So if you have CO2 and O2, CO2 and O2, notice that as you increase the temperature, the volume also increases. The law is V over T equal a constant, and we actually like to put it this way. So V1 over T1 equals V2 over T2. If we cross multiply, we end up with V1 T2 equals V2 T1. And this is probably a quicker form of using, but you know how to do cross multiplication. So let's look at a problem that involves Charles' law. So let's look here. It says a balloon has a volume of 0.785 liters. So a balloon has a volume of 0.785 liters. So this must be V1. So let's write that down here, 0.785 liters at 21 degrees Celsius. So that's T1. Now, before we move on, be aware what we said at the beginning of this lecture that we have to use Kelvin. So you must convert to Kelvin. So convert to Kelvin. Can't use temperature using Celsius. So what you have to do is add 273. And that gives you 294 Kelvin. Here's the action. If the temperature drops, so this must be your T2, and 0 plus 273 is 273K. What is the new volume of the balloon? So V2 is unknown. Before we move on, just because V2 in both these cases was the unknown doesn't mean that always V2 will be unknown in all these problems. You can have P1 in the previous problem as the unknown. You can have T2, T1, depending on what the problem is asking. So again, let's write down the equation. V1 T2 equals V2 T1. And what we're looking for is V2. So We divide each side by T1 to isolate it. So we have V2 equals V1 T2 over T1, and then that would mean, let's start plugging in. V1 is 0.785 liters times T2 is 273 divided by T1, which is 294. So take a minute, look at what we did, divide each side. By the way, get rid of the same units. So here to cancel out the like units, and then the Kelvin would cancel out. And if you do the problem by multiplying what's in the numerator and then dividing the answer by the denominator, you get point 729 liters. So that's V2. We needed 729 liters. This is 3 sig figs because each of these numbers has 3 sig figs. This is 3, 3, and 3. Let's go to the next law here, which is Avogadro's law. And it has to do with volume and quantity. We won't do any problems. We'll just explain this. So this is a relationship between volume and the number of moles. So V and the number of moles. Let's read the statement. The volume of a gas at constant temperature, so T is constant, and pressure, P is constant, so they're both constant, is directly proportional to the number of moles, meaning as we increase the number of moles, the volume increases. And the opposite is true. If you decrease the number of moles, you decrease the volume. You can see this just as simple as a balloon that's inflated versus deflated. The one that is inflated has more weight, has more air molecules in it. So the law is true. Another way of actually expressing this law is by reading the statement here, and it says 1 mole of any gas contains the same number of molecules, which is Avogadro's number, and by Avogadro's law, must occupy the same volume at a given temperature and pressure. So the volume of 1 mole of gas is called the molar gas volume, very important. And interestingly enough is that volumes of gases are often compared at standard temperature and pressure, which we will talk about in the next video, SDP, in case that's given to you. And SDP basically is where you have the temperature as 0 degrees Celsius, which is 273, and the pressure is 1 atmosphere. So notice basically what it's saying. What's saying is that if you actually get the volume of the same volume, let's say, for a different set of different gases, helium gas, when you buy helium balloons, hydrogen, oxygen, carbon dioxide, and ammonia. These are different gases. If you have the same volume, which is the molar volume, that means you have 6.02 times 10 to the 23rd molecules, or in this case, atoms, 6.02 times 10 to the 23rd, etc. So that's what's interesting about the Avogadro's law, which explores the relationship between volume and quantity.